So in this question, we have a graph to start, so we'll analyze it with our Oi Zerga. Our origin is right there at 0, 0. Y-axis is velocity in normal units. X-axis is time in normal units. So therefore, any questions about velocity and time will be just read off the graph. The slope or the gradient is delta V over delta T, which is the acceleration. And the area is V delta T, which has units of meters seconds per second, which is meters or delta X, the displacement. So if the question is asking about displacement, it'll be area. If it's about acceleration, it'll be the slope. So cart moving in a straight line, 5 labeled points into 4 sections. Which segment has the greatest distance? So the greatest distance is going to be the greatest area. And so we have the segments AB, BC, and CD. Now it should be readily apparent, and DE. It should be readily apparent that CD, the area of CD, is less than the area BC. We want to know have the greatest distance, so it can't possibly be choice CD. And if we look at the area of DE, DE is also less than BC, as it corresponds to about that much of the area. So it can't be DE. And so it comes down to whether it's BC or AB. And of course, if you look at that right there, that would be C, and this area is quite a bit more. So area AB is much larger. The next one wants to know about the average acceleration. We said the acceleration is the gradient or the slope. So when we look at these segments, we've got the AB, we've got BC, and the slope here is 0. We want the magnitude of the average acceleration. Magnitude means positive or negative, doesn't matter. So it doesn't matter whether it's positive or negative acceleration. And we want to know ranks them. Well, if we know that the acceleration of BC is 0, that has to be the lowest of the 4. So when we look at the 4 choices, only one of them has BC as the lowest. So that's probably the answer right away. But if we rate, we compare CD and DE, CD is greater than DE. So we're going to look for CD being ahead of DE. It is there. It is there. And it is not here, so choice C is out for sure. And if we look at AB, the average acceleration is delta V over delta T, so that would be like the slope of that line. And we can see CD is steeper than AB, so CD is the steepest. And that is this choice or this choice. So it comes down to next, which one is steeper, AB or BC? BC is not greater than anything, so it can't possibly be this one because it's not BC. So that one's out as well, and that leaves us with BC being the steepest, followed by AB. CD is BC is the least. Let me just start this over again in my elimination. We're looking for BC being the least, but it's also not going to be the most, since it's the least. And it's less than all the others. And the only place it can be is at the end. So really, with BC being here, this is saying that it's faster than DE or CD, which is not true. So that one's out. And CD being greater than AB is true. But BC is the least. It is not greater than DE. That's out. And of course, CD is the steepest, as we said. AB is the next steepest. DE is the next steepest, and BC is the least. Moving on to choice 3, got a kind of a complex kinematics question here where we're going to have to diagram it out. So we have a cart. So we've got position of 0, our positive direction, our negative direction. So time 0, the cart is at 10 meters. So x0 is 10 meters. It has a velocity of 3 meters per second in the minus x direction. So it's moving this way with a velocity of minus 3 meters per second. It has a constant acceleration in the x direction of 3 meters per second, between 3 meters per second squared and 6 meters per second squared. What gives the possible range of position of the car at 1 second? So let's consider the two extremes. If the acceleration is positive 3 meters per second squared, then that means that after 1 second, the velocity will have changed from -3 to 0. So at 1 second, the velocity be equal to 0. It started out with an average velocity, with a velocity of -3 and ended up at 0. So the average velocity is minus 1.5 meters per second. So since the average velocity is delta x over t, then delta x is average velocity times the change in time. And the average velocity is minus 1.5, and the time was 1 second. So it's minus 1.5 meters, which means during this time it moved from a position of 10 to a position of 8.5. So that is if 3. Now, if the acceleration were 6 meters per second squared, then it's positive 6. It would have not only changed to 0, it would have a velocity of positive 3. It would have a velocity of positive 3 meters per second. And so the average velocity would be v plus v0 over 2. The final velocity is plus 3. The minus velocity is, the initial velocity is minus 3, which gives us 0 over 2. So the average velocity is 0, which means its displacement would be 0, and it would be at 10. So that means the range of possible locations for this are between 8.5 and 10, which is choice B. Next question, we have a velocity time graph, so we'll hit our Oizerga analysis. Here's our origin, so we're right in quadrant 1. Y-axis is velocity in normal units. X-axis is time in normal units, so therefore any questions about velocity or time will be red. The gradient, delta V over delta T, is the acceleration in the area. V delta T, meters per second times seconds is meters, so that's the displacement. And of course, I derive these every time, so I remember the process. I don't want to be dependent upon my memory. I can remember one process, or I can remember 100 different graphs. And of course, if I try to remember these values for 100 different graphs, I will lose. I will forget some of them. So we've got a function of time for an object traveling along a straight line. Segments 1, 2, and 3. So let's just kind of highlight these segments 1, 2, and 3. There's segment 1. There's segment 2, and there's segment 3. So we might notice then that the delta t's are equal. So they're all both 2 seconds. All three are 2 seconds. A force on the object. During segment 2 only, a frictional force is also exerted on the object. So, of course, if you exerted a force on something, its velocity might increase. And then there's a frictional force, which caused this thing to slow down. And then it looks like the frictional force was released and it accelerated again. And diagramming that out, it becomes clear that this line is parallel to that line. And since the slope is acceleration, we would know the acceleration here and the acceleration here are the same. So we want to know ranks the displacement of the 3 segments. Oh, displacement is the area. Well, let's consider the area. We have the area of the first, and we have the area of the second segment. Now, we look at the area of the second segment, we can see it is larger than the area of the first segment. It is larger. And we can go further to say that during the first segment, the initial velocity was 0, the final velocity was 4, which means the average velocity was 2. Overall, meaning 2 times 2, the area is 4. In the second segment, we have initial velocity of 4 and a final velocity of 3, which means the average velocity was 2.5. So now you can see the shape of that rectangle has a larger area. 2.5 times 2 is 5. Applying the same thinking to the last, we have initial velocity of 1, a final velocity of 5, which means that the average velocity is 3. So again, we can see looking at those triangles, 2 times 3 is 6, that the area is largest for segment 3. So we want to have the biggest as 3. And clearly from these, 3 is not equal to 1. Actually, they're very different from each other. So those two are out. This says they're all the same, which is also false. And again, we can see the delta x was the largest and area 1 was the least. All right, so we're given that a car from rest, so v0 equals 0. The acceleration is 10 meters per second. What is its speed after it's traveled 25 meters? So there's a couple ways to do this. We could start out with a definition of acceleration, which is delta v over delta t. Now, the acceleration we know is 10. We know that v minus v0 over the time is going to be equal to 10. We don't know the final velocity, but we know the initial velocity is 0. So that means that if v over 2 is 10, then the final velocity is 20 meters per second. And the average velocity is v plus v0 over 2. Final velocity is 20. The initial velocity is 0. So we have 10 over... That's the average velocity is 10. So, using average velocity again is delta x over delta t, then delta x would be v bar delta t. So the average velocity of 10 with a delta x of 25, then delta t would be 2.5 seconds.